When a massive star exhausts its nuclear fuel, its core can no longer support its own weight. Gravity takes over, crushing the star's matter into a region of total darkness. This collapse creates the event horizon, a boundary where the pull of gravity becomes so extreme that even light is pinned in place, unable to escape. To an outside observer, this region is entirely dark and silent. It is a pocket of space severed from the rest of the cosmos, where the trajectory of matter disappears from our view. While the exterior remains an invisible void, the physics governing the interior deviate from everything we understand about the universe. Einstein's equations of general relativity predict that collapsing matter reaches a singularity, a point where density reaches infinity. Most physicists view this not as a physical reality, but as a sign that our mathematical models have reached their limit. Nature rarely allows for true infinities. This diagram highlights a startling parallel. The intense, compressed state found at the center of a black hole shares the same characteristics as the dense seed of our early universe. This suggests matter does not simply vanish at the center. Instead, it may transition into an entirely different state of expansion. By removing the impossible infinity of the singularity, the death of a star and the birth of a cosmos appear to be parts of the same continuous process. Physicist Nikodem Poplavsky has proposed a model where black holes act as generators for new realities. In this model, quantum effects provide a physical limit to how much matter can be squeezed. Particles reach maximum density and hit a rigid threshold. Instead of collapsing forever, the matter rebounds, exploding outward in a rapid expansion known as the Big Bounce. From the outside, the black hole still appears as a dark, static void, masking the events occurring within. But an observer inside that expansion would see a massive, hot, and growing space-time event. Their perspective would define this event as a Big Bang. We observe a similar phenomenon in our own sky. Our observable universe is defined by a cosmological horizon, a boundary that light cannot cross, mirroring the event horizon of a black hole. Our universe's beginning may have been the expansion phase of a big bounce, contained entirely within a parent black hole. This hypothesis addresses the black hole information paradox. Quantum law states that the information describing a particle can never be truly destroyed. This creates a contradiction when matter enters a black hole, as it appears to be erased from the observable universe. In the black hole cosmology model, this data survives. It flows through the gravitational collapse to provide the blueprint for the new universe expanding on the other side. The holographic principle offers another way to visualize this. It suggests that three-dimensional space is a projection of data stored on a distant surface. If our universe exists inside a black hole, our entire reality could be a holographic projection of information encoded on that black hole's interior boundary. Black holes serve as the ultimate preservers and projectors of reality's deepest data. The deep structures of space suggest a different identity for black holes. They function as cosmic seeds, fertile ground for new realities. If our universe was born this way, then every black hole we observe in our own night sky is currently birthing a new universe of its own. This creates a fractal universe, a structure where realities are nested endlessly within other realities. Universes give rise to stars, which form black holes, which then expand into new universes containing their own stars. This chain suggests that reality has no single point of origin. It is a self-perpetuating system of creation. Humanity is one branch on an unimaginable, infinite cosmic family tree. This perspective shifts how we view our place in the cosmos. Every planet, star, and galaxy we can see is part of a structure embedded in a much larger reality, a universe we can never directly observe. We look up at the night sky and see a vast, open expanse, but that expanse is the interior wall of something far larger, the inside of a black hole existing within an even greater universe.